PreAP PreCalculus, looking at free response, practice number 48. You cannot use a calculator for this. The graph of each of the 6 trig functions are periodic in nature. Answer the following questions about the graphs of the trig functions. A, sketch a graph of 2 periods of the function f of x equals sine of theta and g of x is cotangent of theta, beginning with theta equals 0 on the axes provided. All right, so I'm going to graph this one. It's going to be f of theta, which is sine of theta. And I know the period for this is 2 pi. So what I always do for this is I first mark the midline. Midline is the horizontal axis. I don't need to write it so thick. Then on the midline, I just put little marks at the beginning and end of the period of one cycle of a period. Then I put a mark halfway through, and put a mark a quarter of the way through and 3/4 of the way through. Those end up being at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then from memory, I know that sine touches the midline at the beginning, middle, and end of the period. And from memory, I know that sine is 1 above the midline a quarter of the way through, and it's 1 below 3/4 of the way through. If I then take these points for this one cycle, and I repeat this through another cycle, if I repeat the pattern, it's 1 above, then it's on the midline, then it's 1 below, then it's on the midline. So these are the points for 2 periods, 2 cycles. If the point is above, it's part of being concave down. So I like to draw those at the same time. If it's a point that's below, it's concave up. So it looks something like this. This represents sine of theta. The second one we're going to graph g of theta, which is cotangent of theta. Now what you have to remember about sine or about cotangent and tangent, their period is only pi. So I would once again mark the midline. If there's no vertical translations, then the midline is the horizontal axis. And then I would mark on the midline the beginning and end of the period. Remember the period for cotangent's pi. I would also mark halfway point, the middle, a quarter, and 3/4 of the way through. Then from memory, I know that cotangent has a vertical asymptote at the beginning and end of the period. And these vertical asymptotes should be dashed. So let me dash these up. And then also from memory, I know that cotangent touches the midline halfway through the period. A quarter of the way through, it's 1 above, and 3/4 of the way through, it is 1 below. This represents one cycle. The directions we were supposed to sketch it on the axes provided, it says sketch 2 periods. So this is one of my periods. And then to graph another. So if I look at my spacing, every pi over 4, I'm going to have a dot. So if I go to the right pi over 4 and up 1, I'm going to have a dot. If I go on the x-axis, theta axis, I'm going to have a dot at 3 pi over 2. I'm going to have a dot at 7 pi over 4, negative 1. Then I'm going to have another vertical asymptote. Concavity is changing at the midline. There we go. There's part A. As far as points go for this, you would get 1 point if you graphed sine correctly, and you would get 1 point if you graphed cotangent correctly. B, identify the domain and range of these functions. Well, you can either do this from memory, or you can do it from looking at the picture. F of theta, I want to find its domain and range. And G of theta, we want to do the same. For F of theta, the domain's all real numbers, and the range goes down to -1 and up to 1 inclusive. That one's pretty simple. For cotangent of theta, G, the range is pretty simple. It goes from -infinity to infinity, or you could say all real numbers. It means the same thing. The domain for this is going to be all real numbers with some exceptions. Those exceptions are going to happen whenever these vertical asymptotes appear. Now, the first vertical asymptote happens at 0. And when I say first, it could be argued this isn't the first one because this goes on forever left and right. It's just the one that I'm choosing is at 0. And then they are pi apart. So it's 0 plus pi times k. And if you just add 0 to something, it doesn't change its value. So I'm going to say it's all real numbers except for pi k, and then say what k stands for, where k is an element of the integers. Points for this, you would get 1 point for getting the domain and range right for F, and you get 1 point for the domain and range correct for G. C, which other trig function or functions have the same domain as G? Justify your reasoning. Well, let's examine how G gets its vertical asymptotes. G of theta, which is cotangent of theta, has vertical asymptotes when cotangent of theta equals, now remember that cotangent of theta is the reciprocal of tangent. It's x over y. So this happens when y is 0. Y is 0 in the coordinate plane at 0 degrees, and it happens, 0 radians. It happens at pi radians, multiples of pi. So which other trig function also has a y in the denominator? That's what we're looking for. We are looking for another trig function. We want to find another trig function with y in the denominator. Because then when you're dividing by y, you're dividing by 0, the same thing's going to happen. So that is cosecant of theta, because it's equal to r over y. As far as points go for this, you'd get a point for concluding that's cosecant, and you would get a point for saying both of these things here. All right, D. C's not like overly an important type of question. D is a pretty important type of question. Describe what effect A has on the graph of h of theta equals A times sine of theta. What will the domain and range be? Well, we haven't talked about what happens if you're multiplying a number times a trig function. But we have talked about what happens when you multiply a number times any function. How does this number affect the graph? How does that number affect the graph? Well, there's two things. If a is less than 0, then a causes a vertical reflection. And if a, well, the other thing that a can do, as long as a isn't 1, so let's say that. If a isn't 1, then a causes vertical dilations. I forget the terminology we've used for this class. If we said dilations or stretching or shrinking, I'm going to go with dilation. If we use something different, then that's fine. Then A causes a vertical dilation. So what would the domain and range be? Well, the domain's not going to be affected at all. The domain's still going to be all real numbers, but the range is going to be affected. So work with me here. Let's say A was positive. Normally, sign goes down to -1, up to 1. Let's just look at this up here. This is what sign normally does. If we have a 2 in front of this graph's going to go up to 2 and then down to -2, up to 2 and down to -2. So in that case, we would say that the range would go from -2 to 2. Well, what if our A was a -2? Then this graph would go down to -2 and then up to +2, down to -2 and up to +2. So the point that I want to make here is this is going to affect the range. And if we take the absolute value of A, because it could be positive or negative, followed by the absolute value of A, if we leave it like this, we're saying this is the same number. Doesn't make sense. So we want to go range small to big. So we're going to change the sign of this first one. And then the second one's going to be the absolute value of that, and that's what the range is going to be. As far as points go for this, we're going to get 1 point for the domain, 1 point for the range, and 1 point for mentioning could stretch or shrink the graph, and it could cause a vertical reflection. All right, that concludes that free response question.